Yeah. So let's understand that how we can apply the factor theorem to perform factorization. Okay. So factorization by applying factor theorem, that is what we are going to learn now. So let us understand by this, that factorization applying factor theorem, let us understand by means of an example. So let us factorize, the 6x squared plus 17x plus 5 by applying factor theorem. So what we are going to do is that 6x squared plus 17x plus 5. 6x squared plus 17x plus 5. This is the polynomial expression which we are going to factorize leveraging factor theorem. So 6x squared plus 17x plus 5, we can write like this. We can take 6 common. Then you get x squared plus 17 by 6 into x plus 5 by 6. Correct, dear students? So what we can write is that this we can write 6 is into 6 into fx, where fx is x squared plus 17 by 6 into x, okay, and plus 5 by 6. That is what is fx. Now what we are going to do, we are going to see that how we can express fx. Here in that fx, the coefficient of x square is 1. So what is fx here? Fx we see is equal to x square plus 17 by 6 into x plus 5 by 6. And definitely it has two factors, because two linear factors I can say, because fx is a quadratic polynomial, so it must have two factors. What are the factors it has? Suppose its factors are x minus a into x minus b. Correct, not dear students? That we are sure that it should have a two factors, x minus a and x minus b. But what is our task here? Our task is that to find the value of a and b. If we find the value of a and b, we are done. We are able to factorize fx, and eventually we'll be able to factorize the original expression, which is 6x squared plus 17x plus 5. So fx we have expressed in terms of x minus a into x minus b. And how we are able to express this thing, because factor theorem allows us to write like this. Because fx equal to what? X squared plus 17 by 6 into x plus 5 by 6. So now as the coefficient of x square is 1, so there should be two linear polynomial in which the coefficient of x should be always 1. So that's why we wrote x minus a into x minus b. I repeat, factor theorem allows us to write like this. Now after that, what is our task? Our task is to find the value of a and b. Now how to find the value of a and b? That should be our discussion for the next few minutes. So what we see is that if you see in the right hand side, what is the constant term? So if you expand this thing, so let me write like this. So this implies what? This implies x squared plus 17 by 6 into x plus 5 by 6. That is equal to, if you look into that, it is x squared minus of a plus b into x plus a into b. And our concentration is on a into b. If you recall, dear students, that x squared plus 17 by 6 into x plus 5 by 6 is equal to x squared minus a plus b into x plus ab is an identity. Now, as it is an identity, definitely the constant term in the left hand side should be equal to constant term in the right hand side. Correct? So what we can conclude? We can conclude that yeah, AB is equal to 5 by 6. Correct or not? Now we need to find the different factors of 5 by 6. Okay. What are the different ways we can write A and B so that their product is 5 by 6? So what are the possible values we can find? We can find the possible values as plus minus 1 by 2. Let me write properly. What are the different factors we can get? Plus minus 1 by 2, plus minus 1 by 3. Correct, no? Plus minus 5 by 3, plus minus 5 by 2, and 1. These are the different factors possible, no? Dear students. Plus minus 1, obviously. So what I wanted to mean is that you can take a proper choice of value of A and B from all these numbers, that is plus minus 1 by 2, plus minus 1 by 3, plus minus 5 by 3, plus minus 5 by 2, and plus minus 1, so that you can get A into B is equal to 5 by 6. Now let's see how we can achieve this. Let us find just as a trial method, what is the value of f of 1 by 2? Okay, so the value of f of 1 by 2, what is fx? So let me write it down. Let me go back to this one. What is the value of fx here? The value of fx, what we get is that x square plus 17 by 6 into x plus 5 by 6. So this implies what? This implies, let's find the value of f of 1 by 2. If you find the value of f of 1 by 2, so it will be something like that, 1 by 2 whole square, that is 1 by 4, plus 17 by 6 into 1 by 2. So that is equal to 17 by 6 into 1 by 2 plus 5 by 6. And what is our objective? Our objective is to see whether that f of 1 by 2 is equal to 0 or not. Why? If it is 0, then we can say x minus 1 by 2 is a factor of fx, which is not. For that we don't need to calculate. Na? This cannot be equal to 0. 1 by 4 plus 17 by 6 into 1 by 2 plus 5 by 6. We don't need to compute. Obviously, all are positive terms. It cannot be equal to 0. Then let's find the value. So x minus 1 by 2 is not a factor of fx. Then what we are going to do? Now let's find f of minus 1 by 3. If we find f of minus 1 by 3, we will see that minus 1 by 3 whole square is 1 by 9, minus 17 by 6 into 1 by 3. Correct, no? And plus 5 by 6. And that value, if you find, it is equal to 0 actually, if you compute. So now what we can say? We can say if as f of minus 1 by 3 is equal to 0, so we can say this implies x plus 1 by 3 is a factor of fx. Is a factor of fx. In the similar manner, we will find just by trial what are the different factors. So we'll take the factors from here. We take the factors from here. So we tried with 1 by 2, we didn't get 0. We tried with minus 1 by 3, we get 0. Like that, we can see that, if we find f of minus 5 by 2, then also we'll find it is 0. Just by trial and error method. If we find f of minus 5 by 2, okay, and we will find this is actually coming to 0. You can find it out, minus 5 by 2 whole square. So let me write it down, minus 5 by 2 whole square plus 17 by 6 into minus 5 by 2 plus 5 by 6. And if you see, this is actually equal to 0 if you compute. So from here, what we can say? We can say yes, that x plus 5 by 2 is a factor of fx. So dear students, these two statements are very important. We found x plus 1 by 3 is a factor of fx, and we also found x plus 5 by 2 is a factor of fx. And what is our fx? Fx is x square plus 17 by 6 into x. So now what we can do, we can club these together. From here, these three, we can conclude what? We can write fx is equal to x plus 1 by 3 into x plus 5 by 2, isn't it, dear students? So what we can write from here? So we can write fx equal to x plus 1 by 3 into x plus 5 by 2. That is the value of fx. Actually, we can write it from here. Now, as we are able to write fx equal to x plus 1 by 3 into x plus 5 by 2, so from here, that 6x square plus 17x plus 5, which is nothing but, so what we have seen earlier, we have seen that 6x square plus 17x plus 5, that is equal to 6 into fx, no? So what we can write? So then eventually we can write from this statement that, let me write it here, that 6x square plus 17x plus 5, this is equal to 6 into x plus 1 by 3 into x plus 5 by 2. So that you can simplify further. So, and you will get something like this, 3x plus 1 into 2x plus 5. Absolutely clear. But dear students, if you see that 6x square plus 17x plus 5, you take this expression, polynomial expression, and do a middle term factorization, that is by splitting the middle terms, you can find that factorization quite efficiently, correct or not? But then why we apply the factor theorem? Because we will see in some cases where the factor theorem is efficient. Factor theorem is efficient means that in the constant term we can make a factorization, and we'll see that it is efficient way of doing it. But before that, to understand that splitting the middle term is efficient in context to this question, what we can do quickly is that we can take this 6x squared, the given expression, 6x squared plus 17x plus 5, we can do quickly factorization that we have done earlier, that is equal to 2x plus 15x plus 5, because 17 has been expressed as 2 and 15, because 2 plus 15 is 17 and 2 into 15 is equal to 30, which is equal to 6 into 5. So from there, from the first two term, we can take quickly, we can take 2x common, so we'll get 3x plus 1, and here also we can take 5 common, we get 3x plus 1. Then from these two terms we can take 3x plus common, and we get 2x plus 5. See how efficiently we are able to factorize it using by splitting the middle term. Result, we got the same thing, same result we got. Here also you get the same result, here also you get the same result. But we'll, as I said few minutes back, now we are going to see one example where application of the factor theorem is efficient, okay, and we'll see it now. Suppose we need to factorize x cube minus 23x square plus 142x minus 120. Think about how we are going to factorize it. Whatever the knowledge of factorization we have now, is that the approach should be something like this. Let's look into the constant term, which is the minus 120. And minus 120's factors, what are the minus 120's factors that we should be concentrating on? So what are the factors of minus 120? Factors of minus 120. If you look into the factors of minus 120, what we are going to get? Plus minus 1, plus minus 2, correct? Na? What are those? Plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 5, plus minus 6, plus minus 8, plus minus 10. Never hesitate to correct me in case I am missing something. Plus minus 15, plus minus 20, plus minus 24.
Sir,
Yep.
what about 12?
Yes. So correct you are. Appreciate. Thank you very much. I missed plus minus 12. Thank you. Okay, appreciate you. So plus minus 24, plus minus 30, and plus minus 60. Correct or not? So now, if you look into all these factors, what you need to do, dear students, is that you need to try with the first few factors. Generally, whatever the questions will be given in the exam or in any entrance exam or in your talent search examination or your board examination, you just try with the first few factors and find the value of these polynomials on those factors. So let's take fx equal to x cube minus 23 into x square plus 142 into x minus 120. Correct, no? So now what we are going to do, dear students, is that we are going to find the value of fx at x equal to 1. Value of fx as x equal to 1. So that means here we are going x equal to 1. Why? Because 1 is a factor. Let's see what is the value of f1. So it is 1 cube minus 23 into 1 square plus 142 into 1. These are all multiplied, by the way. Okay, minus 120. So what we are going to get? The value what we are going to get is that, 1 minus 23 plus
0.
very good, 0, na? Great. So as it is 0, fantastic. So that means what? X minus 1 is a factor of fx. We are fortunate here. But dear students, some questions you will get, okay, with 1 you are not able to get, then try with minus 1. Then also you are not able to get, then try with plus 2. You are not able to get, then try with minus 2. Then one way of this thing you will get it. You should not go up to, you need to apply F12. It will not be. Some will not be given like that. So with first few factors, plus 1, minus 1, plus 2, minus 3, minus 2, plus 3, minus 3 maximum. Beyond that, it will not go. So, but here we are fortunate. We get only for the first factor, we get the value of fx equal to 0. So from here, what we can say? We can say x minus 1 is a factor of fx. Then what we are going to do is that, dear students, is that we can now take x minus 1 common from these factors. So there are two ways you can do it for factorization. Is that you can divide this polynomial, that x cube minus 23x square plus 142x minus 120 by x minus 1. You can divide like that. Then what you will get? You will get a quadratic polynomial. Correct, na? You got my point, what I'm telling, dear students. So what I'm saying is that if you divide that x cube minus 23x square plus 142x minus 120 by x minus 1, then what you can write? You can write something like this, na? X cube minus 23 into x square plus 142 into x minus 120. That we are going to get x minus 1 into some quadratic polynomial. Correct or not? You will get x minus 1 into some quadratic polynomial. There will be no remainder. Why not remainder? Because x minus 1 is a factor. So how to get that quadratic polynomial? For that you need to make a long division. Long division of what? Long division of x cube minus 23x square plus 142x minus 120 by whom? By x minus 1. And I'm not doing that division because this is not a class for doing division. Then we should be just wastage of time, because we are learning something new about how to apply the factor theorem to factorize. Then if you do this long division, you will get something like this. The quadratic polynomial will be x square minus 22x plus 120. X square minus 22x plus 120. Now x square minus 22x plus 120, that you can factorize very easily using the splitting the middle terms. Correct or not? So if you just concentrate on splitting the middle terms of this one, x square minus 22x plus 120, what we are going to get? That we are going to write is that x square, you can write it is 12 and 10, I hope, right? 12 and 10 is actually 120, and their summation is also 22. So x square minus 12x minus 10x plus 120, that is equal to x, you take common x minus 12, minus 10, you take common x minus 12. Then from these two terms, you take x minus 12 common, and you get x minus 10. So finally, what is the factorization we are getting? Finally, the factorization we get x minus 1 into x minus 10 into x minus 12. Correct or not? So that you can apply it here. So finally, what we are going to get? The factorization of this. From here I can write this is equal to x minus 1. And whatever we get it from here, we can just write it. That is x minus 10 into x minus 12. Now tell me, dear students, if you are not aware of the application of the factor theorem, how could you actually factorize this one? Was little difficult, na? Because just by splitting the middle terms is not possible here. So this is one classical example where you need to make sure that what are the different factors of the constant term, which is 1 minus 120 in this case, and then how efficiently you can factorize this thing and try with the first few factors and finding the value of the polynomial. I repeat, you may get f1 equal to 0, you may not get f1 equal to 0, then you try with minus 1, then you try with 2, then you try with minus 2, you will get definitely 1. And then the moment you get one linear polynomial, I'm talking about the cubic polynomial. The moment you know one cubic polynomial, you are dividing by a linear polynomial, that the quotient has to be a quadratic polynomial. The moment quotient is a quadratic polynomial, then factorization of the quotient, which is a quadratic polynomial, is quite easy because splitting the middle terms. Now think about that not only cubic polynomial, a biquadratic polynomial is given to you, for example, for the sake of discussion. Okay. So suppose a biquadratic polynomial is given to you to factorize. Let me talk with a very generic term so that you will be able to connect it properly. Okay. So what I'm saying is that suppose a biquadratic polynomial is that ax power 4 plus bx cube plus cx square plus dx plus e. And the task is to factorize this biquadratic polynomial. Then what you will do, dear students? First, your task would be to factorize the constant term and find of the few of the factors and find the value of fx. So in this case, find the value of fx. If you get the value of fx for that particular factor is equal to 0, then you can say that if suppose in this case we see that if you get one such factor is that suppose p. If p is equal to 0, then what you can conclude? You can conclude that x minus p is a factor of fx. X minus p is a factor of fx. The moment you know that x minus p is a factor of fx, what you can do? You can make a long division of fx by x minus p. If you do a long division of x minus fx by x minus p, what you are going to get? You are going to get something like this: fx equal to x minus p and a cubic polynomial. Correct or not? You'll get a cubic polynomial. So let's take that cubic polynomial is that suppose something like that, q into x cube plus r into x square plus s into x plus t. Suppose. Now what you will do, dear students? Then what you are going to do is that take this cubic polynomial and let us factorize this cubic polynomial. Then you will ask, sir, how to factorize the cubic polynomial? Not a big deal. Factorize the constant term. And the constant term will be what? T by q. Okay, because you take q common, then the coefficient of xq will be 1. Factorize it. One we did it, not today, the previous example. Factorize it, then you will get a linear factor. The moment you get a linear factor, then if you divide by that, then what you will get? You will get a quadratic polynomial. Suppose this polynomial, suppose we get this polynomial, its name is at gx. We give this polynomial is gx. Gs is equal to q into x cube plus r into x square plus s into x plus t. Suppose for this cubic polynomial, how to factorize this cubic polynomial is actually we are saying is that by means of that factor theorem. We just say one example here. This is example. So you need to split the you need to make the factorization of the constant term. Once you do, then what you are going to write? You can write is that gx we can write is that you can take q common so that the coefficient of xq should be equal to 1. So suppose you get a factor here is that x minus suppose l. Then whatever you will get it here, that will be a quadratic polynomial. Correct or not? That has to be a quadratic polynomial. And not only quadratic polynomial, I can say that has to be a quadratic polynomial with the coefficient of x square should be equal to 1. So what it will be? It will be x square minus, I give some m into x plus m into x plus n, suppose. Now it is pretty simple to factorize this particular term x square plus mx plus n. That you can use middle term factorization to factorize. Correct, na? So you will get two terms. Suppose this you can express as x minus u into x minus v. So now after that you join all these things, you will get the factors. So if you join all these things, so finally what is the factor of fx you are going to get? The factor of fx you are going to get is equal to q into x minus p into x minus l into x minus u into x minus b. Correct, not, dear students? And you can actually eradicate q by taking the LCM of this PL, UV. They will be in fraction. Okay. So this I give a generic idea that if you get a biquadratic polynomial expression also, how you can utilize the factor theorem to factorize it. I hope it is absolutely clear. Any doubt, please do let me know. Any simplest doubt, never hesitate. Okay. Now, as an example, we can solve this particular problem, that x cube plus 13x square plus 32x plus 20. So I give this an exercise to you. Could you please solve it and send me your solution? You can send me your solution over WhatsApp to me as well. You need to make a neat and clean solution, take a photo and send it over WhatsApp. And I have the right mechanism to put that, whatever you are sending into the digital board in real time without any delay. I can immediately keep it here. Take a couple of minutes and solve it. Did you get it? Anyone? Okay, I can help you then. So did you get any factor?
Got -1.
Fantastic. -1 is a factor, correct.
Yes, sir. I got -1 too.
Great, fantastic. So the moment you get a -1 as a factor, then what you will do? You will
You
divide,
divide the thing.
correct.
And I got x square plus 14x plus 46, but I got remainder of 66.
That means things have not been done properly. You would see it here. X plus 1 is a factor, no? So x plus 1 is a factor, then x cube plus 13x square plus 32x plus 20. What you will do? Here you will write x square, no? So that we will get x cube plus x square. Then minus x cube got cancelled, so you get 12x square plus 32x plus 20. So what you will do here? Plus 12x. So then what we are going to get? 12x square plus 12x. Correct or not? Then minus 12x square got cancelled. 32x minus 12 base is 20x. 20x plus 20. So what we'll write here? Plus 20. So we say 20x plus 20. Then minus, finally you will get 0. So then what we can write here? We can write that initial cubic expression is equal to x plus 1 into x square plus 12x plus 20. Now our concentration is on x square plus 12x plus 20. How we can factorize it? That is quite simple, I hope, because by splitting the middle term, we can express 20 as 10 and 2 such that 10 plus 2 is 12, right? So x square plus 10x plus 2x plus 20, that is equal to x into x plus 10 plus 2 into x plus 10, that is equal to x plus 10 into x plus 2. That's it. We are done. So this is equal to what? This is equal to x plus 1 into x plus 2 into x plus 10. All of you got it?
Sir,
Any?
yes, sir.
Yes, please. Yes.
Sir, the factor which we got was x -1. Sir, why did you put x plus 1?
Oh, okay. Thanks for your question. Okay. First of all, thank you for asking question. See, if you recall the factor theorem, if we get if a equal to 0, then if x minus a is a factor. So we for -1 we got 0. So x minus of -1. Let me write it down. Then you'll understand. I got your question. What is your? I got your question. So let me get back to you to the factor theorem. Yeah. Look into here. X minus a is a factor of fx is fa equal to 0. Correct, no? So now what is a here? In context to our question, what is a? A is -1, no? Because f of -1 is 0. So then what will be factor? X of -1, that is x plus 1. Let me write it down. We know.
Okay, sir, I got it. Thank you, sir.
Got it, na? X minus of -1. Got it?
Yes, sir. Yes,
Good,
thank you, sir.
good. That's why we divide by x plus 1. And also, dear students, please look into the 2 YouTube videos what I discussed today during the class, that you should look into it, because there I discussed a particular case is that if you divide by 2 2x plus 3, suppose. Always you may not get that x minus a, na? Suppose you divide fx by px plus q. What will be the remainder? So that thing I discussed very well in this YouTube videos. Please have a look into it. Okay,
So in
so
your YouTube video, like in one of them you used some discriminant law or something. I don't know what that is. So I didn't understand that.
okay, so the best way to mention this thing, is that once the class is done, you can exactly point me to this video and tell me, sir, look into from this minute to this minute and explain me. Got it, no?
Okay, sir. Thank you.
Because generally my YouTube videos actually happen for 1 hour, 1.5 hours, as long as my class is actually executed. So and that's why it is better to, you can point me, sir, exactly in this point, this time to this time I didn't understand, you explain me, then in the next class I'll explain. But whatever the videos I share, please look into it, watch into it, that you will get a very clear idea. And I hope all of you are aware now how to look into the YouTube, all the video lectures into the online test platform, or you want me to take you through that? All of you are aware or not aware? Okay.
Yes, sir.
You are aware? Okay, great. Then fine. And if you are not aware, then there are some YouTube videos to look into it, that how to use the different features of online test platform from www.KonarClasses.com. That you will also get it. Okay, so in the next class, dear students, what we will be discussing, we'll be discussing about the algebraic identities. That is also very important, extremely important for for algebraic computations. So that we'll be discussing in the next class. And today, if I summarize, we have discussed quite a very important topic today. So we started with remainder theorem. Then we discussed that what is remainder theorem. Then I also pointed you to the relevant YouTube videos of my earlier classes where I described in details about the remainder theorem. Then you discussed about the factor theorem, and I also explained you about the significance of the term called IFF. Also, we discussed about the necessary and sufficient condition, implying and implied by. These are little advanced concept of mathematics, but not very advanced. You'll also know in another 2 years from now. And then I point you to another YouTube videos where I described in details about the factor theorem. After that, we started discussing about the factorization of the polynomials. And we see that there are two ways we can factorize a polynomial, one using the splitting the middle term and the other one using the factor theorem. So for quadratic polynomial, generally it is good to use splitting the middle terms. But for cubic polynomial, it is efficient to use, factor theorem. And with this, I would like to conclude the class for today. In case you have any specific question or specific comments for me, please do let me know. And very important statement I would like to mention before I conclude the session for today. You see that just a minute, let me show you the screen, and I stopped showing that digital board. I'm going to show you another website of KonarClasses.com, and I'm going to say one important message. Okay, so before that, please confirm that you are able to view the web page of KonarClasses.com.
Yes, sir.
Okay, great.
Yes, sir.
So yeah, all of you have login, so you can log in. Suppose I log in with a demo login, suppose. And what you need to do is that, I hope you get emails now the moment you complete an test, right? And once that your marks is also given, you get an email. So you can look into that email, and in that email there is a link. In that link you can click, and which will take you to the paper, or you can come to the my reports and look into that my last 1 week performance. if you look into my last weekend performance, here it is not there. Suppose if I look into my last 1 month performance, that is also not here. So you'll find your report here, by the way. Your your test result, you will be able to find it here. So if you go to my online exam performance, so there are a lot of papers here. So in this paper, suppose if you see the real number DPP paper, okay, suppose wherever you see that 0 out of 0 of 1, whenever you see that your marks is less than 1 in any question, you should analyze why the marks is less than 1. And if you get a reason to find it out, fine. If you do not get a reason to find it out, please be in touch with me. You can always raise, sir, I thought I should get 1, but here the marks has been deducted. So why so? You should please point me those. So whatever the your DPPs I have evaluated so far, dear students, for all of you, you find that sometime you get deducted 1.5 marks, sometime 2 marks, like that. So don't stop it there. Please deep dive to understand where this 1 marks or 0.5 marks, 0.2 marks actually getting deducted. I'm not saying just because of marks. Marks is not that important as long as the DPP is concerned. But what is important, dear students, is that to understand where the mistakes happened. That will help you to, eradicate those mistakes in your, future when you solve similar type of problem in future. So with this, I would like to conclude the class for today, dear students. If you have any specific question, do let me know. Otherwise, we'll have our next class on Thursday, and that is the day after tomorrow at 3 o'clock in the afternoon. Thank you very much.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.